Hi guys, I'm glad y'all are here today for the review of parts 2 and 3 of the departmental review. I did want to point out, and of course this is good for my students, which all of you are sitting here, is your final exam review material. So what we're using is this departmental review, but I also have this semester summary posted. That's sort of like notes that kind of summarizes everything we've done, and so some of you might find that helpful. So don't forget to take a look at that. It also shows you the different things that you need to know. Okay, so we're going to actually start on paper here because I'm going to do part 3 first. So the multiple choice questions, if you guys have any problems with those, you can email me about those and I'll answer your questions that way, because we're not going to have time to go over those. But I wanted to go over the parts 2 and 3, and I'm starting with part 3 only because I've got to do it on paper, so it's a little different from the other ones. And also this one in your free response part of the final tends to be the heaviest point-wise, because they'll ask you several of the questions that you see here. You'll see a graph and you'll see several questions, and those will each be worth 2 points apiece. So that can add up to like 8 points on the test. So I did want to start with that. Okay, so we've got this graph and we're asked, what is the domain? Now remember that domain is the x values that correspond to all these points. So we scan coming in from the left. There is an arrow that's indicating that the graph continues on outward in that direction. So that means there's no leftmost point. So I'm going to use negative infinity in that situation. Okay? So we're going to say the domain doesn't have a left bound, doesn't have a leftmost point. So we're going to say it's negative infinity to 3. Okay, it stops at 3. It is a smooth curve. There are no holes. So it's everything coming in from the left until we get to 3. All those x values are included in the domain. And so we're going to use interval notation. You never use a bracket with infinity or negative infinity. Now remember, with domain and range, you've got to decide whether to use a parenthesis or a bracket. And you use a bracket if this is a closed-in point. What they're saying there is that point is included. Remember, if they put the open circle, that would mean it's not included. So I am going to put a bracket at 3. Now range is all the y values. And so what you want to do is scan from the bottom up. And of course this thing has an arrow that indicates it goes on forever in the downward direction, and so that means the range doesn't have a bottom point. If it did have a bottom point, I would start at that. I would start at that y value. So I'm going to say negative infinity until I get to this highest point, but be really careful when they're on an axis. We tend to switch those. Okay, that is the point 0, 3. It doesn't hurt to write the points, write more so you can see visually and engage more parts of your brain. So the range then is from negative infinity all the way up to 3. And it does include 3. Okay, now when you're asked on what interval or intervals is a graph increasing or decreasing, remember that's referring to x, because when we say increasing, we mean the function or the y value is going up as we come from the left to the right. So as we're going from left to right, this graph goes up, 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 up. That's increasing until we get right there. So we're going to go ahead and say that we know that this function is increasing from negative infinity until we get to, now here's where you got to be really careful, because our eyes want to come up here to the 3, but remember you're telling the x values that are making y increase. So you'd say 0. And you never, ever use a bracket with increasing, decreasing. And that's because what is happening right there? Neither one. To the left, the function's increasing. To the right, it's decreasing. Okay, and so now we're going to say it's decreasing the rest of the way. So we're just going to write it's decreasing from 0 until we get to 3, the x value 3. Okay, what is f of 0? Remember, this is function notation. This is your input, your independent variable, which is your x value. So that's an x value of 0, and it's asking what y is paired with that. So you look at 0, you go to your picture, that's paired with 3. So f of 0 is 3. Okay, f of negative 3. That's asking what y value is paired with the x value negative 3. So we were given the point. There's negative 3. It's maybe a little bit off. 1, 2, 3. It'll be clear on your final exam. But it's showing you that that point is negative 3, negative 1. And what do you guys say about f of 4? Here's 4. Is there a point? Yeah, that's a little trick question to get you to think. Okay, that does not exist. Okay, now what are zeros? Zeros are x values that make y 0. Can 0 be a 0? Yes. Does 0 have to be a 0? No. Okay? And I think some of you missed that on test 3. On the last polynomial inequality, you missed the fact that 0 was a 0 because x was one of the factors. So look at that on your test, see if you missed that. Okay, so for this, what we're going to do is we're just going to look on the x-axis, because all along the x-axis, that's where y is 0. So that's occurring at negative 2 and at 1. Now remember, this is representative. So you could go back into your test reviews, your, what else could you use? You could use old tests, but look at other pictures. Don't just think about this one picture. Don't memorize, okay? Think about what a 0 is, because maybe there'll be more zeros, maybe there'll be fewer, okay? You got to make sure you hit them all. All right, so the zeros then are negative 2 and positive 1. Okay, what is the y-intercept? Well, an intercept, remember, is where a graph crosses an axis. So if it's a y-intercept, here's the y-axis, it's that point, and so we say it's the point 0, 3. And remember, x-intercepts are points also. They're related to the zeros, but the way we write the answer is a little bit different. Okay? So there we have that. So now we're going to move on to part 2. And if you guys have a question as I'm going through, do not hesitate to ask. Okay? Because otherwise I'm just going to kind of plug through this thing. Yes, sir?
I saw in the email it said that it's on a Scantron, so is it all multiple choice?
No, in the front, if you look on the front of the packet, it tells you it's in Canvas. Look in the last module. There's 27 multiple choice questions, so that's for the Scantron, but then there are also 14 short answer questions, and that's what we're going over today, are the short answer type questions. Okay, so moving on to part 2. I'm sort of going backwards here. This says solve for C. Okay, and that's 5 minus C over 3C plus 1 is equal to A. So we've got to rearrange this equation in order to get it solved for C. So that's our goal. Our goal is to get C equals everything that's not C. And so the guideline that I've given you guys is what you think about is you think about simplifying the equation. Then you move terms around, keeping the goal in mind. Then you factor. And the last thing you're going to do with these multivariable equations that you've had is divide, the last thing you're going to do. Sometimes people try to divide too quickly. That says divide there. This particular problem requires that we do all 4 of those. But you did, back in the homework, you did have problems where you didn't necessarily have to do all of those. Okay, but you should sort of think through them all. All right, so simplify. Well, it's a fraction. That's not simple. So I am going to get rid of the fraction. And most people find it a little easier to think about cross multiplying. So what I'm going to do is write the a over 1. And then I'm going to cross multiply. And that gives me a times 5 minus c equals 1. Sorry, I did that wrong. A times 3c plus 1 equals 1 times 5 minus c. So I'm just going to write 5 minus c. Now, sometimes you need, with equations, you need to multiply this out. You had some logarithmic equations where it was easier not to. So it's always a matter of kind of taking a look at what you've got and where you're going. With this one, I definitely need to multiply things out because I've got a c on this side and a c on that side, and I'm trying to get c by itself. So I'm going to continue to simplify. So I'm going to multiply this out, and I get 3ac plus a equals 5 minus c. And so that's as simple as I can get that equation. So now I'm moving on to moving terms. And so I want to have c terms on one side, and any terms that don't have c are going to be on the other side. And I'm just going to write what I'm doing so this doesn't get super messy. I'm going to subtract a from both sides to get it to the right-hand side, and I'm going to add c. The other 2 terms are where they should be already. And so we get 3ac plus c equals a plus 5. So now I've moved terms around, so I've only got c terms on the left. Now you factor. So you factor out c because we're solving for it. And here's a place I see a lot of people make a mistake because they get 1 and 0 mixed up. They think if I pull c out, there's nothing left. Okay? But if you had nothing left, you could multiply it back. You wouldn't have a c here. Okay? So it's got to be a 1. And then we divide. So I'm taking both sides and dividing by 3a plus 1. And so I finally have that c is a plus 5 over 3a plus 1. Yes, Levi?
Subtracted a from both sides. Minus a plus 5.
Oh, did I do it wrong? You guys catch me faster, sorry. Yes, you're right. That should be it. Is that my only mistake?
Yeah.
Oh, that's easy to correct, right? Okay, so we're going to put, thank you for catching it though. That's a negative a. And so I could write it, the way I have it written is all right, or I could write it as 5 minus a on the top. Thank you for catching that. Please catch all my mistakes. This is being recorded. Okay. Second question. We're solving 6x cubed plus x squared equals 12x. Okay, if it's not linear, then you're probably going to factor. So I'm going to subtract the 12x from both sides. Because I'm about to use factoring method. Now, factoring method is based on something that's true. It's based on the fact that if you have a product equals 0, then you know one of the factors has to be 0. Okay, so I'm looking at these 3 terms, and the first step in all factoring, remember, is look for a GCF. I do see that we have a common factor of x. So I'm going to factor that out. And so there's one of my solutions already because x is a factor. So that means 0 is one of the solutions. And now we have to factor the 6x squared plus x minus 12. Nope, that's not it. Oh yes, that is it, isn't it? I got to get my signs in the right place. Some of you learned to factor trinomials by AC method. Others did trial and error. But always check your middle. 9x minus 8x gives me the positive x in the middle. Because sometimes you'll get the factoring right, but the sign's backwards. So make sure you double check that. All right, so we're going to set the factors equal to 0 and solve. So 3x minus 4 equals 0. I add 4, divide by 3. I'll get 4/3 as one solution. Now I'm not going to get through this one and find I did it wrong, am I? No mistakes? Okay. Subtract 3. And divide by 2. So there we go. So we got 3 answers. Now remember, it was a third degree equation, so you could have as many as 3 real numbers that are solutions. Okay? What's that?
We do have 3 real.
Yes, we do have 3 reals. Yes, we do. All right. The next one you have to do with the calculator, and unfortunately I don't think we're in a room that has the calculator. I don't know how well this is going to show up. Let me see. Pretty sure we don't have the calculator here. No. All right, let's just try it. Let's see what happens if we can see. Can y'all see that at all? You can? Okay, so I'm going to type in y equals x power 5 minus 3x power 3. And then I'm going to hit zoom 6 to put it in the standard window, which often helps. And I can actually see everything. Okay. Now to know where this is increasing and decreasing, I need to know what those relative extrema are, the relative max, relative min. So this is where you do second trace. I'm going to find a relative maximum first. And remember, the issue is that you have to be to the left of a maximum. The function should be increasing there. So you either tap to get over there, or you can also just plug in an x value. And I'm going to hit enter. And then I'm going to go to the right where it's decreasing and hit enter. And then I'm hitting enter again. And I'm going to jot down the point that I have there. Okay, so they did not, in the directions did not tell us how to round, but I'm looking in the answer and they rounded to 3 decimals. So we're jotting down that point. So I'm writing down the point negative 1.342 and 2.898. And then I'm going to find the minimum. So I do second trace, choice 3. And I'm to the left, and now I'm going to get over here to the right where it's increasing. And then I'm going to hit enter again. And I get that the relative minimum occurs at this point, 1.342, negative 2.898. All right, so let's just do a rough sketch of that so we can answer the questions that they're asking. They may have asked us the zeros too. Let's take a look. No, it just asked us that. Okay. So a rough sketch of number 3. Is not showing up very well. Let me do a better job on that. I just wanted a rough sketch of this because I don't want to just talk about where the relative max and min are and then the intervals of increase and decrease. It kind of, I did not mean to make that look like it was doing something funky there. Okay, so it's increasing first, and so we say that's negative infinity until we get to that x value, negative 1.342. This is where it's increasing. And then it increases again after this relative minimum. And so we're going to say union 1.342 forever. So we put an infinity for that. And it's decreasing in between. So that's from negative 1.342 to 1.342. And then I think it also asks for the relative max and the relative min. So you would say the relative maximum is 2.898 approximately. And the relative minimum is negative 2.898. Okay? Okay, for number 4, you have to remember some things about lines. So let's jot those down here. And you were asked for these on the QEP also because you need to know them. Remember, you've got y equals mx plus b. That's the slope-intercept form because m is the slope and 0b is the y-intercept. So if you know those two things or can find them easily, you can just use that equation. The other equation is y minus y1 equals m times x minus x1, which comes from the slope formula, which we'll also put up here because you might have to find the slope. Remember, slope is the difference in your y's. You can write that as delta y over the difference in your x's. And you can write that as delta x for short. The other thing about lines is remember that parallel lines have the same slope. And perpendicular lines have slopes that are opposite in sign and, if we're not thinking about the sign, reciprocal. Really what it is that if you multiply the two slopes together, you get -1. So like 1/2 times -2. That's the real that's the mathematical definition. But I like to write it out in words to remember what to do. Okay, so number 4, it says write the equation of the line in slope-intercept form that goes through 3, -5, and -3, 3. So what do we know about this line? We know 2 points. Do we know the intercept, the y-intercept? No, we don't know the y-intercept. Can I find the slope? Okay, so let me write the second one above the first one. Remember, the order doesn't matter, but it matters that you put the difference in the y's on the top and the difference in the x's on the bottom. So I'm going to say the slope is 3 minus -5 and -3 minus 3. Okay? And so that gives me 8 over -6, which reduces to -4/3. Next, it's your choice how you want to find the b value. Some students like to just use y equals mx plus b. How would I use that formula to find b? What do I do? Okay. So you pick one of your 2 points. Okay, this equation has to be true for all points on the line. So if I pick this first point, for example, I'd put in the 3 for the y, and then I'd put in the -3 for the x, and then solve for b, like you said, and so that's -1. But if you do that, don't forget, you're supposed to be giving the equation, so the answer is y equals -4/3 x minus 1. How many people prefer that way? You guys do? Okay. But the other way that a lot of you have learned is using the point slope formula. And so the only difference there, I'm still going to use one of the points. It's just that I'm going to solve this for y. So let's just use the other point just to show that we get the same thing. So we'll use 3 -5. So I'm plugging in -5 in place of the y1, -4/3 in place of the slope, and I'm using this point, 3 -5, so x1 is going to be 3. And then I have to simplify, so I get y plus 5 equals -4/3 x, and then it's minus 4/3 times -3. Multiplying here, I would get plus 4, and then subtracting the 5, I get the same answer. Y equals -4/3 x minus 1. So that's your 2 ways. Okay. All right, and then the second question, we want to know the equation of a line that is perpendicular to this line and it passes through 6, 1. Is anybody confused about what the directions are telling us on this one? Sometimes I feel like people aren't quite sure what they're asked to find. We're finding the equation of a line that is perpendicular to this line. Two different lines, okay? Now, what do we know about perpendicular lines? Their slopes are opposite and reciprocal. So what's the slope of this given line? It's already in the y equals mx plus b form, so that'd be -3/2. So what's the slope of the line that we're looking for? Yeah, 2/3. So we're going to use m equals 2/3, and we're going to use the point that was given, the 6, 1. Remember, if you get lucky, if that's a 0, you're done, right? If this was 0, we know the y-intercept, and we can just plug into y equals mx plus b really easily. Okay. So now it's just a matter of doing one or, either use the y equals mx plus b. Okay. And those of you that use that usually don't need my help. Okay. So I'm going to just do it real quick the other way. The y minus y1 equals m times x minus x1. So using y minus 1 equals 2/3 times x minus 6. I'm going to solve it for y. So multiply the right-hand side first. I'm going to get 2/3 x minus 4. And then I'm going to add the 1, and I'll be finished. Look back on test 1 and see if you missed that, and redo it, okay, if you did miss that one. Okay, number 5 is from the last unit. We're going to solve this for x, 5e to the x plus 2 equals 40. That's called an exponential equation. I cannot write both sides with the same base. So what am I going to do?
Move the exponent to the side.
Not yet, right? That's getting a little bit ahead of me. Yeah, divide by 5. I didn't have too many of you get started out wrong with that. If you took the log of both sides at the beginning, here's what's wrong with that. If you took the log here, you can still work the problem, but you have to understand that that x plus 1 doesn't get to come down yet. This is a product of 5 and e to a power. That's why we say isolate the e to the power first. It's a little bit easier, because I would have to break that down into log 5 plus log e to the x plus 1 equals log 40. If you remember your rules for, or your properties of logarithms there. And then you got to finish that. I mean, you can do it that way, but most people make a mistake. So we want to get the e to the x plus 2 alone first. Now, take the log of both sides, because what we're using here is the fact that if those are equal, then the natural log of those two sides would also be equal. And I get to now bring that power down. So that's x plus 2, natural log e equals natural log 8. What is the natural log of e? 1. What does natural log e mean? It means the exponent, you have to raise base e2 to get e. So that's 1. Okay? And so now we've got x plus 2 equals natural log 8. And we still haven't solved it quite for x. What's the one last step? Subtract the 2. Good. Subtract the 2. And I had a few people a little confused about exact versus approximate. That is exactly what x is. To get an approximation, we've got to go to the calculator. And the answer's in the back, so I'm not going to do that part. Let me make sure this is still on.
The red light is flashing.
Yeah. Yeah, she said that didn't matter, so I guess it's okay. It's on F1. Okay. That's what I had to check. I was afraid I changed that. All right. Number 6. It's easy to mix this one up. It says, or to forget something on this one. This is a 4th power. And when you all got to the 2nd unit in this course, we started talking about complex solutions. So if it doesn't say find all the real zeros, that means you got to find all the zeros, which would include the complex ones. We're finding zeros, which means all the zeros, but it means you want to find out what x values make the y, which is the f of x, equal 0. And we're going to do this by factoring. So first thing I'm going to do is factor it as x squared minus 4 times x squared plus 1. Okay, let's check the middle. X squared times 1 and negative 4x squared does give me negative 3x squared in the middle. Now, those are quadratic factors, but there's no x term, and so you can use square root method on those. Because you can't factor x squared plus 1. You could factor x squared minus 4. So let's just do them the same way. Let's set both of them equal to 0. That's factoring method, right? I'm going to isolate the square. So I get x squared equals 4 on that one. And I'm using square root method. I'm not taking the square root of both sides. I'm using something that's true. If this number squared is 4, then this number, x, either needs to be equal to the positive or the negative square root of 4, which is plus or minus 2. And we can do the same thing with this one. If I subtract 1, I get x squared equals negative 1. And so x is plus or minus the square root of negative 1. But we simplify radicals. And how do we simplify the square root of negative 1? Yeah, that's I. So we would say that's plus or minus I. So there actually are 4 solutions, or 4 zeros to that function. 2 of them would not be seen on a graph because they're not real. But if you graphed that function, you would see these 2. Okay, number 7. We're going to, even though I could use my calculator on number 7 and find the minimum, I'm not going to do it that way. Because I want to make sure everybody knows how to find the maximum or the minimum for a quadratic. Because you do not have to use your calculator to do that. I mean, you don't have to use the graphing feature. So we've got 80,000 minus 120x plus 0.055x squared. So it's not in the correct order. Let me go ahead and rearrange that, just so we get our A, B, and C correct. Now what this is, it says, is it gives me the cost, and X is the number of sodas produced daily. So what is the number of sodas that minimizes the cost of producing them? It's a quadratic, so you're going to use X equals minus B over 2A, the vertex formula. Your other option is graphing. So on this problem, A is 0.055 and B is negative 120. So that's the opposite of negative 120 all over 2 times the .055. You do, when you type this into your calculator, you do have to be careful that you put parentheses around the denominator. Be really careful about that, because sometimes people will type in, like, everybody see that this is positive, which makes sense because it's a number of sodas that we're figuring out. So it should be positive. But the two negatives make it positive, and so you want to do 120 divided by parenthesis 2 times .055. Close the parenthesis and then enter. And what did that give you? Is it a decimal?
1,090.909.
Okay. So we're just going to round that. We're going to say 1,091 sodas. Now, how do I answer the second question? It asks, what is the minimum? So how do we do that? It says, what is the minimum cost? No. So you figured out, what did we figure out here? This is the vertex, right? And this is a parabola that opens upward because the A value is positive. So right here at the vertex, you've got a minimum, right? So we can find a minimum cost. What we did was we found the X that gives us the minimum cost. So now to find the minimum cost, we would find C of 1091. And I'm not going to go through that. All you do is plug it into the formula, and you can use your calculator. Okay? And you got the answer there. Okay, number 8. It says solve the quadratic equation algebraically. Okay, remember that this is going to be a free response question. And so I'll be grading your work, and it's going to say solve algebraically. So these are your options when you've got a quadratic. If it factors, you can use factoring method. Now, do you think it's going to factor? No, because we have other questions that are going to test that. Okay? The second method is, well, now you know how to use the quadratic formula. That's probably going to be your preferred option. Preferred to the third possibility, which is completing the square method. And you do need to know completing the square method for another problem, but you don't have to use it on this one if it just says solve algebraically. Now, in completing the square method, we have square root method. We use the square root method. And sometimes square root method works, but it wouldn't on this one because we have an x term. We'd have to complete the square. So what I'm going to do is I'm going to get 0 on one side by subtracting the 7x from both sides. And then this doesn't factor. And so I'm going to go on to the second possible way of solving it algebraically. So I'm going to use quadratic formula. So here's our review of the quadratic formula. It's a big fraction, okay, and in the top, the opposite of b plus or minus is shorthand, remember, for two separate solutions. The square root of b squared minus 4ac. I have too many people putting a plus there. Okay, b squared minus 4ac, and that's all over 2a. So we're going to plug in, and then we'll simplify if we need to. Let's write down what a, b, and c are. A is 1, b is -7, c is 13. So this will be the opposite of -7, plus or minus Okay, I had a lot of you guys messing up on this right here. You're squaring that b. So that term right there is always positive. If you type it into your calculator without parentheses and it's a negative number, your calculator is going to do what you tell it to do. If you put opposite of 7 squared into your calculator like that, it's going to say that's, or it's going to use negative 49, which is not what you mean. Okay, it's the negative 7 is being squared. So you have to understand that that's, you know, the calculator's doing exactly what you tell it to. And you want it to square negative 7. You don't want it to take the opposite of 7 squared, which is what that says. Okay? Minus 4 times 1 times 13. And that's all over 2 times 1. Okay, so let's figure out what that calculation is there. See, it's 49 minus 42, is that right?
49 minus 52.
Oh, 52, right.
So negative 3.
So negative
3.
3, okay. All over 2. Yep. And so the last thing we're going to do is say that's 7 plus or minus square root of 3 I all over 2. And at this point, I'm okay with you leaving it like that, but technically we should write it in the a plus bi form. And a plus bi form is both terms over the 2. 7 halves plus the square root of 3 over 2i. And the other one is 7 halves minus the square root of 3 over 2i. That's the shorthand for that. Let's just real quick talk about a simplification, just in case you come across one of those. Instead, this one didn't have a whole lot of simplifying to do. We only had the negative to deal with. So let's just remember, what would you do if you got like a 50 under here, let's say? What do you do with that? That requires simplifying. 50 is 25 times 2, right? You factor out the perfect square factor. And so this would be 4 plus or minus square root of 25 square root of 2 over 2, which is 4 plus or minus 5 square root of 2 over 2. Now, resist the urge to cancel there because it doesn't cancel here. So if you always separate it the way I did here, then you won't go wrong. Okay? All right, number 9 is another quadratic. So to answer it's a word problem, and to answer the questions, you're just going to need the vertex. So just for the sake of time, let's just write down what you need to do to answer, because we just did one like this with the cost function in number 7. Okay, this one is the height of a projectile is given by this formula. And the first question says, after how many seconds will the projectile reach its maximum? Well, this time you've got a negative, and so this is the type of parabola that opens downward, and so we do have a highest point at the vertex. So to answer question A, you would use that t is minus b over 2a. A is negative 16, b is 98, because that will tell you after how many seconds it reaches the maximum. Part B asks, what is the maximum? And so what you're going to do to that is, once you know this number, then you find S of that number. And you've got the answers in the back. Okay? So that's just finding the vertex and answering the question correctly. All right, on number 10, let's look at completing the square method. You guys ready? Now? Okay. Okay, completing the square. We got x squared minus 64. Sorry, I read that wrong. Minus 6x equals 34. Let's just kind of do an outline of completing the square. So in completing the square method, remember you take, and this is on the QEP, guys, I asked you for this on the QEP that's due today. You take half of the b value and then you square that. So this is what you're answering for me there. When I said what completes the square for x squared plus bx, it'd be half of b squared. So you find that number. But then what you're trying to do is you're trying to get a quantity equals a constant and use the square root method. So everything you do should be keeping in mind what the goal is. So it's this expression that I complete the square for. That number, if it had been on the other side, I would have gotten it over on the right-hand side. Just get it out of the way. But in this problem, it's already over there. Okay, so now what we're going to do is we're going to turn this into a perfect square trinomial. So I take half of negative 6, which is negative 3, and I square that. That's 9. That is the number that turns the left side into a perfect square trinomial that factors as a binomial squared. That's the whole point. But I can't just add 9 just because I want to. I've got to keep things balanced, right? I had a 34 over there. So if I add 9 to the left side, I've just got to add 9 to the right side also. So I've written the perfect square trinomial. I've written it as a binomial squared. I'm going to just add these two. That's 43. Thank you. That's 43. Now we're going to use square root method. We have a square equals a number. So the thing that's being squared, the x minus 3, is either equal to the positive or the negative square root of 43. It's not quite solved for x yet. What's the last thing? Yeah, just add the 3. And so that can look like that, if you want to be safe, okay? Or it can be at the front. Just make sure you don't do this. If we had something like 2 plus 3 square root of 5, sometimes people want to add those, which isn't correct because this is a product. So you'd have to leave that alone. That does not equal 5 times square root of 5. Okay. All right, let's find an inverse. You guys, especially in the hybrid class, you guys did pretty well on this. Some of you didn't put your cube root low enough. You need to be really careful about that. Yeah. Okay, that's fine. I did want to keep track of time because I know some of you guys, I'm going to stay here until we finish this because we've got the room until 2:30, but I know some of you, you know, it's 1:24. That's what time it is. Okay, so the inverse is x equals y cubed minus 2. That is the inverse. It's taking all the xy pairs and it's turning them around. But we have to solve it for y.
Homework would have for the 2 parts. The first would be
Right. That's right. So we're going to add 2. And then I need to undo the cubing to the y because I want just plain old y. The opposite of cubing is cube root. So I'm going to take the cube root. Really what I'm doing is taking the cube root of both sides. And some students put to the 1/3 power. That's fine. That is the same thing. Some people raised it to the 1/3 power. But that undoes the cubing, and so we've got that y is the cube root of x plus 2. The only thing left to do is replace y with the function notation, which is f inverse. Yeah. Mm-hmm. Okay, you guys ready for the next one? Is that good on that one?
I have one more question.
Yes.
So why can this just be taking the cube root of both sides instead of the
Oh, the square root, that is a very good.
both sides without having to make it plus minus?
That's a good question. It's because with cube roots, there's only one answer, right? You know, like if you had a cube root of -1, that's not plus or minus. That's just -1. So it's only with the even roots that you have to think about the plus minus.
Okay, so if I had to take the fourth root
Yes.
of both sides, then that would
Right.
be plus minus?
That's right. That's why you didn't see any of those, because that is an issue. Okay, and it gets a little more complicated with the higher powers, yeah. Because we can, well, we won't go there. Okay. All right, so let's look at number 12. 12, we have 2 to the x plus 3 equals 11, and I can't write 11 as a power of 2. So this is where I use taking the log of both sides. I had some students just seeing that that's an exponential form and rewriting it as a logarithmic form. There is nothing wrong with that. There is nothing wrong with that at all. I had some of y'all, that's why I put an OK on your paper, because you just did it differently than I would have done it. Okay, but you could say that's log base 2 of 11 equals the exponent and then solve it. I had students do that. That's okay. But the method that we showed you was kind of just sort of a process. And so I'm going to do it that way because that's the way we learned it originally. So I have these two sides and that I want to bring that exponent down. And so what I do is I could use log, okay? Doesn't matter because that's on your calculator too. But I'm going to use ln. If this was an e, I would definitely use ln because things simplify more nicely because those are inverses. But what we said was you have those two things that are equal, and so the natural log of those two things would be equal, and then we can bring the power down. And then we need to solve for x. Now, a few minutes ago, we did a different problem where I multiplied things out. This problem, I think, is a little easier if we go ahead and divide by the log 2. Because look what happens. Okay, see that would divide out. And then you've got x plus 3 equals the natural log of 11 over the natural log of 2. And then what do you do to solve for x? Just subtract 3. And that is the exact value. If you multiply it out, that's fine also, and then solve it for x, that'll work. Your answer's going to look a little bit different, but I count it right, okay? And that's finished. Now, if you're not careful, though, in getting the approximate answer, remember, you need to go natural log, and you've got to close that parenthesis. And then natural log, and the first parenthesis pops up, and you type in the 2, but you need to close the parenthesis. and then minus 3, and then enter. And that'll get, you can get an approximation and you can check it. Did anybody want to talk about this form? What else would you have to do here? Subtract 3. Yeah, subtract 3. Now, why are those two things equal? What's the change of base formula?
Log of the log unit divided by the log of the base.
Mm-hmm. So those are equal. That's why I was okay with that. Okay? All right, number 13 is a logarithmic equation. And remember, we either have all logs or some logs. If we have all logs, we work with it until we set the arguments equal. The base doesn't ever matter. But in this problem, it does. And a lot of you got it, at least part of that right. But we still lost some people, so let's look. Oh, that's a 2. This is a sum logs problem. Meaning that's not written as a logarithm. Okay, so this is a sum logs problem. If you've got a sum logs problem, you've got to use your base, and some of you did forget that on the test. Okay, got to use it. So first, we're going to put these together. That'd be the log base 3 of x times x minus 2 equals 1. Then use the log rule. The base to the exponent equals the argument. So that is 3 to the first power equals x squared minus 2x. X times 2 is 2x. That's where I lost some people too. 3 to the first power is just 3. So I'm going to subtract it. And then we're going to factor. Now we're using other methods because now we have a quadratic equation, and so I'm factoring. And I set the factors equal to 0 and solve. But remember, just because we get an answer in this new equation doesn't mean it works in the original. You've got to check your arguments. Make sure they're positive for these values. The arguments originally were x and x minus 2. If your x is -1, that doesn't work. So we would throw that one out. 3 plugged in for x, that's positive. Plug it in for x here, 3 minus 2 is positive 1, so that's fine. So the 3 does work. A little caution on this one. You could have a problem. I'm not going to do a whole problem because I'd have to make it up and I might not come out with nice integers, okay? But you could have a logarithmic equation that looks like there's no base. So it's 10. So don't forget, if it's a sum logs problem, like this one was, you need the base. So if it just says LOG, remember that's log base 10 of x, which is another thing I asked you on the QEP. And that's the reason, is so you're ready for that. You guys doing okay? All right. Whew, we got a little bit to go here, and I'm gonna rock on through if it's okay with you guys. Okay. I know some of you have to leave. That's okay. All right. I'll see you next week. Okay. Graph 14 says to graph these two on the same graph. It's not necessarily that that's what you're going to do. It's just to have you doing the two and remembering how they're related. Okay, there's a few problems in here that are like that, where they're just trying to get you to remember some things. So they're saying graph 1/3 to the x and also graph 3 to the x on the same graph. And to label everything. Be really careful for me on showing me where asymptotes are. That's where some people lost some points on test 3, is they didn't draw in their asymptote, or they didn't treat the asymptote correctly. You know, to show that If you've got an exponential, then you have a horizontal asymptote. If you have a logarithm, you have a vertical asymptote. Okay? So these are exponentials. One has a base less than 1. Remember, our bases are always positive. This one is a base bigger than 1. And so the difference is this exponential will increase. When we have a base less than 1, it decreases. And I'm talking about the basics, not if we reflect or shift. Well, reflections mainly could change that. Okay, so we're gonna, this one's pretty easy to type into your calculator. It asks you to do some points. So you would just do, you could do 1 divided by 3 power x, and then look for some integer points in the table to graph, okay? And of course, 3 power x is the other one. So that's how you can graph it, and you can look in your table and get your points. Do I need to say anything else about that? You've got the answers in the back. Okay, so remember this one decreases, the second one increases. And then you should draw more points. This is the asymptote, which is the line y equals 0. Yeah, Ruth Ann?
How do you find the x-intercept if y can never equal 0? Is there just not one?
There isn't an x-intercept.
Okay.
There's a y-intercept, but not an x-intercept. And so if we didn't shift left or right or up or down, it's going to be at 1 on the y-axis.
Okay.
But remember, it doesn't, you're right, it doesn't ever touch the x-axis. That's an asymptote. Okay? So make sure you show that. I did not do a very good job on that one. That should look more, yeah. Like that. It's coming down towards the asymptote. Okay. And then the number 15 is similar. They have, except this one, they're having you graph a basic logarithm and then graph one that's got a shift. So let's talk about using your calculator to help you find some nice points. You can use the change of base formula to help you find nice points to graph. But you've got to draw your asymptote correctly, and I don't want to see what you see in the calculator, which looks like the points are just running out, remember. So the calculator's your assistant. You can use it to help you and to help you find points, but you need to know what these pictures look like. Okay, so that's the change of base formula, remember, that you can use to type it into the y equals and then use the table. And so what that one's going to look like, this one's not too bad for us to actually figure out some points without going to the calculator, because it's 2. Okay, so I'm going to think of powers of 2 here. Okay, your basic logarithms cross the x-axis at 1. The asymptote for the basic logarithms is the vertical line x equals 0. Okay, 2, 1 would be a point, and this is labeling. That's what they mean by label everything. So the point 2, 1, the point 1, 0. One more point would be 4, 2. And when I draw it, I'm going to make sure I don't just make it look like that, which is what the calculator will do. It'll just look like it's running out. No, I want you to show that it's approaching that asymptote. And this is continuing on in that way. Okay? The other one is a shift of the base 2 logarithm. Which way is it shifted? X minus 2 shifts, yeah, right, goes to the right. There's my trick. And that's going to be your asymptote too. If you take that argument, set it equal to 0, solve it. That's your asymptote. Okay, so that one crosses at 3. And if you're going to use your calculator to help you find points to plot, you can use change of base on this. It's log of the argument divided by log of the base. And then you can look in your table and get some good points. But I'm just going to shift these points that I already graphed. So I'm going to shift that one over 2. I'm going to shift 2, 1 over 2. And I'll shift 4. 4, 2 over 2. So that'd be at 6, 2. And I'm going to draw in x equals 2, which you'll need to do. So there's the asymptote for that function. So there's the second one. Question on that? No. Okay, inequalities. Oh my goodness. We have to be more careful with inequalities. X cubed is greater than or equal to 4x squared minus 3x. First of all, you have to have comparison to 0 for the polynomial inequalities. So I'm going to subtract 4x squared and add 3x. In comparison to 0, I am looking for positive y if this calculation is y. Okay? We want y is greater than or equal to 0. Now, the only places where a polynomial function can change sign from positive to negative or vice versa is through the zeros. And so the next thing you need to do once you get it in comparison to 0 is you need to find the zeros. Those are your critical numbers, your critical values. In higher math, they'll call it partition points sometimes. Okay, so we're going to factor out x. And then I have a trinomial to factor. It factors as x minus 3, x minus 1. And so the critical values are 0, 3, and 1. Those are the numbers that make those factors 0. On the number line, let's put those in order. We got 0, 1, and 3. And I had some people testing, which is fine. They plugged in numbers, but they weren't getting the right answer. So if you're doing it that way, make sure that you're understanding, you're looking for where it's positive and negative. That's what matters. So you could still, even if you're not going to use graphing method, you could still use your table to help you to figure that out. Okay, so you could type in the y equals this polynomial and then use the table. But I'm just going to draw the picture that you would see if you graph this. So this thing's going to cross at 0, at 1, and at 3. Of course, the y-axis will be right here. And what you'll see it looks like is this polynomial will come up, then back down, and then it'll turn around one more time. If you graph it on your graphing calculator. These are negative y's because we're below the x-axis. These are positive y's up here. This piece right here is positive. Negative. This piece down here is negative. Negative y values. And then over here, it's positive again, forever. We were looking for positive. So the solution is the x interval from 0 to 1. We did have an equals, so I need to put a bracket because the zeros are included. So 0 to 1, all of those x values are producing positive y's. If you plug in 0.5, if you test it, you should get a positive number. and then everything past 3. So that's from 3 to infinity. So if you plugged in a 4 into the x cubed minus 4x squared plus 3x, you should get a positive number there. And any number you plug in above 3 should give you a positive number. And so that's the solution. It's always intervals, unless there's no solution. Okay, solve in interval notation. Okay. Absolute value of 3x plus 2 is greater than 7. Now, I know that I'm glad I have some of my online students that are going to watch this and that are sitting here right now, because what we did in the hybrid class was a little bit easier than what you might have seen in the whatever video you might have watched. Okay, the way we did this was and this is what I explained in the notes, is absolute value has to do with distance. And so what this is saying is this is a distance away from something. Okay, and it's a distance that's greater than 7. So if I'm standing here in the middle of a couple of numbers, okay, say I'm smack dab in the middle, and I want to know what numbers are 7 units away from where I'm standing, that's going to be that direction and that direction. If it's what numbers are less than 7 units away, that's going to be inside. Okay, so what you have to find here is what makes 3x plus 2 come out to 7, and what makes 3x plus 2 come out to negative 7. That's where the plus minus come in. When you're doing square root method, it comes in at the end. When you're doing absolute value, it's at the beginning. And that's because, look, the absolute value of 7 is 7, and the absolute value of negative 7 is also 7. So I'm looking to see what makes this expression come out to those two numbers first. Okay? And so I'm going to figure that out. I'm going to subtract 2. I get 3x equals 5. And then divide by 3. I get x is the number 5/3. With this one, if I subtract 2, I get 3x equals negative 9, and then divide by 3, I get x equals negative 3. So let's plot those on the number line. Okay, negative 3 is below 5/3. I know those two numbers would make this equal 7. That's what those two numbers do. They make it equal 7. Anything in between has an absolute value or a distance less than 7. And then anything out here has an absolute value greater than 7. And you can even plug in a number if you want. If you get confused or something, as long as you remember that first part correctly, you know that those are the two most important numbers, then you could test something. Like you could test 0. Let's do it. Let's look at this and see if it makes it true or not. 3 times 0, because 0's in here, right? 0's in between those. Plus 2, that would be 0 plus 2, which is 2. Is 2 greater than 7? No. Okay? So what we have then is that the numbers below negative 3 work and the numbers above 5/3 work. And then you have to describe that. So that's negative infinity to negative 3, union 5/3 to infinity. Okay? Determine the equation of a circle with radius 6 whose center is 3, negative 1. Circles. Now that one's here in the free response part, and that seems more like a multiple choice question to me. That's your center, okay? Remember that the circle formula comes from the distance formula. And the distance formula comes from the Pythagorean theorem, which is a squared plus b squared equals c squared. Okay? And for this one, all we got to do is plug in. So we got x minus 3 squared and y minus -1 squared equals 6 squared. When I asked you a question like this on test 1, I made you give me the circle formula, plug it in, and then you were supposed to simplify. So the only thing to do to simplify, you don't multiply this out. You don't want to do that. You just, if there's minus a minus, that's the only simplifying you need to do. And you would square your 6. And so that's the way the circle equation would appear in its simplified form. Okay, number 19 has a part that should be easy, but we got to be careful about plugging it into our calculator correctly. And then there's another part that involves solving an equation. Okay, so part A says, what is the amount of money in this account? This is the directions tell you this is an investment account that tells you the amount of money P after T years. And it says, what is the amount of money in the account after 4 years? So that's a T value. So we're finding P of 4. So that's just typing it into the calculator and using the E key. So I'll write down the keystrokes for you. So you would type in 5,000 times, you're going to have to use second function, and then the ln key, because E to the x is above the ln key. Now what's going to happen, I'm going to put this in green because a parenthesis will come up, a left-hand parenthesis. And so you type in 0.05 times 4, and then you've got to close that parenthesis, and then you press enter. And then just round however they say. Usually with money, you're either rounded to the nearest whole number or the nearest cent. This one they did to the nearest cent. The directions will be clear on the exam. $6,107.01 is what we get there. But the second part is more involved. It says, when will the account reach 10,000? So that's what T gives a p-value of 10,000. This is almost the same as that problem that I asked you guys where I said, how much time does it take money to double? Same kind of thing. Except here we're going to, well, that is doubling, right? 5,000 to 10,000 is the doubling time. So we're plugging in 10,000 for P, and we've got to solve for T. Got to solve this for T. So don't forget to divide by the 5,000 first. Otherwise, you're going to have to use more properties than you really meant to. So we're going to divide by 5,000 in order to get the e to the power by itself. Oh my gosh, I had so many people subtract instead of divide. Okay, that you're dividing. That's a product. You're dividing by 5,000. So that's 2 equals e to the 0.05t. We've simplified it a little bit. Now I want that exponent to come down, so I'm going to take the log of both sides. Let me do it over here. So we get the log of 2 equals the log of e to the 0.05t, which is log 2 equals 0.05t. Power comes down. That's a property of logarithms. Times natural log of e. Natural log of e, I would like to see that in your work, please. It doesn't disappear, okay? The reason it goes away is because it is equal to 1. The natural log of e is equal to 1. And then the only thing left to do, let me write it out here. We're trying to solve for t, so we just need to divide by 0.05 now. And then you go to the calculator because you're trying to answer a word problem. You don't usually leave word problems in exact form. You usually do the, the approximation. Because you're answering a question and you want an answer that makes sense to people.
It would be 13.86.
Okay. Yeah, and just look at whatever the directions are for rounding. Okay? All right, and then let's look at that famous number 20, which I've given you on test 1, and then I gave a couple of my classes had to do learning outcomes quiz that had to do with this last problem. It's the population problem, and I have people that misinterpret the t-value, and that's what the problem is. And I think what I know is going on is I think they go to their homework, and they keep looking at the answer and going, oh, this is what we always get, okay? And I'm trying to get you to understand that you only know the y-intercept, which is the b-value, if the first coordinate is 0, okay? So in this problem, it says the population of Quincy has shown a linear increase in these years, 2004 to 2014. In 2004, the population of Quincy was 6,885. Let's just write down that information. So this is the year. It's 2004. And the population that year was 6,885. By 2014, it had risen to 7,955. Okay, so this one is a rise in population, so we're going to get a positive slope. Sometimes you have the decline in population, so you get a negative slope. Okay, so it says, find a linear equation P as a function of T, the number of years since 2005. So what we're looking for is this linear model. P of T equals slope times T plus the intercept value. That's what we're looking for. Now, here's where people go wrong. It's the number of years since 2004. It's not 2004. So that's 0. It's been no years at that point. That's the beginning year. In 2014, that's 10 years later, bless you. And so that's why I make my students write their points out. And I think I get more people that way, but I still have people making a mistake here. It's because this is 0 that we know that's the b-value. So we're not going to have to find it. We are only going to have to find the slope. So let's find the slope. The slope is the change in your dependent variable, which is p, divided by the change in your independent variable, which is t. So that would be, let's go this direction so we have fewer negatives. 7955 minus 6885 over 10 minus 0. See, what happened when you're doing your homework is when you subtract the years here, of course you're going to get 10. So you get the right slope, but then it's like, scratch my head, I don't know where the b came from, okay, because you're counting 2004 as the t value. And what does that slope come out to?
1,070.
That's the final answer, or is that the top?
No, it would be 107 per year.
Okay. So 107 is the slope. So remember, that does mean that the population is rising by 107 a year. So our formula then is P of T equals 107T plus 6,885. I know that's the b value because the first coordinate is 0. And B says, what will the population be in 2019? So you're going to use your formula. Okay, 2019 minus 2004 is that right? Is 15 years. So you find P of 15 and the answers in your packet. So let's just run to the last question. The last question is just having you think about the situation in real terms. Okay, so it's applying what you know and what you found mathematically or can find. It says, when, in what calendar year, will the population reach 9,000? So we would have to solve 9,000 equals 107t plus 6885 to help us answer that question. So let's go ahead and figure out how many years that takes. That's what this equation would give me, right? I'm going to be able to figure out how many years it takes to reach to this population, that p-value. So I'm taking 9,000 minus 6885. And I'm going to divide both sides by 107. Okay, now that's coming out to 19.8 something. Okay, but what did the question ask? It said, in what calendar year? So it's going to happen between 19 and 20 years, right? So it reaches 9,000 population between 19 and 20 years later. So what calendar year is that?
2023.
What is it?
2023.
2023?
That's 19.
Okay, good. So 2004 plus the 19 is where we're going to get 2023. It's sometime in that year. Okay, and we could kind of figure it out with months too there. Okay? That's it, guys. Did anybody have any multiple choice questions they wanted me to do? They tend to be more basic than the ones that we just went over. If you look at number 23 in the multiple choice, it says, let me show you real quick. This is why on the QEP I asked you to think ahead. Just a couple things I'd like to look at with you real quick. I asked you on the QEP, I've forgotten which number it is, I think it's in the 30s, but I said which of the functions that we've studied are not one-to-one. That's because I want you to be able to look at this quickly and see, okay, remember your cubic function, y equals x cubed? Okay, it just goes like that. You know, it increases. It's one-to-one. And so if we multiply it by 5 and we subtract 2, we're stretching and we're moving it up, but that wouldn't change the fact that it's one-to-one. One-to-one means every y had only one x paired with it. So a parabola, see the parabola? Not one-to-one. This is a line. Okay, vertical lines are not functions. Okay, horizontal lines aren't one-to-one. Okay, they've got every x value is paired with the same y value. But slanted lines that aren't vertical and horizontal, those are going to be one-to-one. This one you may not recognize as well, but that's that reciprocal function. Do you guys remember that one? Y equals 1 over x. Way back. Okay, as unit 1, y equals 1 over x. Anyway, that's shifted and stretched, but it is one-to-one. So these three are all one-to-one. The parabola is not. So that's why I wanted you to think. Parabolas, absolute value, horizontal lines, that pretty much covers the not one-to-ones that we've done. Yeah.
I had a question about the QEP. On one of them, it was asking, like, it was log base A and then A. What is
That's
it?
1.
1. So
right?
that's all you're asking us to do was that? Okay.
Yeah.
I just didn't know what you wanted.
If you, bless you, if you look on the log properties notes on the first page, you're going to see all those.
Okay, awesome.
That's what you're putting on that.
Okay, thank you.
Okay. All right. Bless you.
So we're,
Are you putting this online as well, or is that straight online soon?
What we just recorded will be posted.
and then our next class is just our exam.
That's right. And it actually meets during your class period, which is weird, but it does. See ya. See you next week.